Okay, so finishing off question number 18, we found the final velocity that the stone had as it was falling through the air. So in the water, it goes to a quarter of that. So a quarter of 28.014 is 7.00357 meters per second. And the question wants to know, what's the depth of the water? So delta D is equal to VAV times delta T. Rearranging, VAV equals delta D over delta T. So we're taking that 7.00357 meters per second and multiplying it by 1.1443 seconds. And when you do that, you get a depth of the water to be 8.01428. I didn't round it all there. Meters. Okay, so not far from 8 meters. All right? So those are the questions from the back of the sheet. Now the other thing I asked you to do was on the examples to finish up to example number 6. So everybody had up to number 3 right before they left class. So I promised I would do 4, 5, and 6. So number 4 says, oops, look at that. It says, two objects start from rest some distance apart and travel towards each other. So you have number 1 and you have number 2. Maybe I'll just move this back out here. There we go. And I'll try not to mark off the page. So number 1, start from rest. So VI is 0 and VI is 0. Two people are 400 meters apart. So this distance between them, 400 meters apart, and begin to run towards each other. The first one, A1, accelerates at 0.3 meters per second squared. The second one accelerates at 0.2 meters per second squared. How long before they meet? So we don't know T1 and we don't know T2, but we know they must be equal to each other because they start at the same time and they meet. And we know delta D1 plus delta D2 must be equal to 400 meters. So we need an expression for delta D1, and it's going to be VI delta T plus 1/2 A1 delta T squared, and the VI is 0. An expression for delta D2 is going to look very similar, except it'll be A2, and the VI is 0. So we're now going to take this and fill it in where D1 is, and this and fill it in where D2 is. So 1/2 A1 delta T squared plus 1/2 A2 delta T squared equals 400 meters. We're trying to solve for T squared. You could multiply everything by 2 if you wanted to get rid of the 1/2. Factor T squared out. You don't have to multiply, you can leave them here. And that will equal 400. And now divide by the bracket. So it'll be T squared is equal to, I'm multiplying now, 800 meters, and on the bottom, A1 plus A2. And now fill in your numbers. 0.3 meters per second squared plus 0.2 meters per second squared. On the bottom is 0.5, dividing by 0.5. It's the same as multiplying by 2, so 1600 seconds squared. Take the square root, T is equal to 40 seconds. Go back to the question. It says how long before they meet, how far has each traveled? So now go up here and take your 40 seconds and fill it in. So 1/2 0.3 meters per second squared times, whoops, that's supposed to be a 40 seconds squared. 40 seconds is 1600, half is 80, 800 multiplied by 0.3, so 80 times 3, delta D1 is 240 meters. Over here and do the same thing, delta D2, there really is a 1/2 there. 1/2 0.2 meters per second squared times 40 seconds squared, so 1600, 800, 2 times 80. Delta D2 is 160. You can now do a little happy dance because these two distances actually do add up to be 400. And remember I said don't ever take this and subtract it for 400 because if you do that you won't know if you had screwed up or not. Okay, so that's number 4. Number 5 says an object is stopped, the second one passes it, and the first one accelerates to catch up. So you're on your porch, which is right at the edge of the road, when a friend jogs by. So it's you and friend. If you are on your porch, VI is 0. Your friend jogs by, going 3 meters per second. That's the VAV for the friend. They're in a nice even pace. You immediately start out to catch up, accelerating at 0.3. So your A is 0.3 meters per second squared. And it wants to know how far have you traveled before you're up to your friend. Okay, so remember, so this is you, and this is your friend. So your friend goes by, and then you run to catch up. You're behind, but you eventually catch up. The times will be the same, and the delta D's will be the same. So delta D for you is VI delta T, 1/2 A delta T squared. This goes to 0. Delta D for your friend is just going to be VAV delta T. And they must be equal. So delta D of you must equal delta D of the friend. So 1/2 A delta T squared is equal to VAV delta T. You're trying to solve for delta T. Divide both sides by delta T, because it'll cancel then this one out, and it'll cancel that T squared out. Okay, so you'll have 1/2 A delta T is equal to VAV. Multiply both sides by 2 and divide by A, so 2 VAV over A. So 2 times 3, that's about 6, divided by 0.3 meters per second squared. 6 divided by 0.3 is the same as 60 divided by 3. The time is 20 seconds. Okay, so that's the first part. And then it says how far have you traveled. So delta D1 is equal to 1/2 0.3 times 20 seconds squared. 20 squared is 400. Half of 400 is 200 times 0.3. So that's like 3 times 20. Delta D is 60 meters. If your friend did the same thing, you're good to go. So 3 meters per second times 20 seconds. Woohoo! 60 meters. And you got it right. All right. Number 6 says, 2 cars are both traveling 18 meters per second. Oh, look at that. I can use this now. But one's behind the other. So car 1, car 2. One is behind the other. So VI 18 meters per second. VI2 18 meters per second. And this is 40 meters back. The one behind decides to pass and accelerates at a rate of 4 meters per second squared. The other doesn't like this, so A2 also accelerates 2 meters per second squared. Okay, so remember, this will be delta D2, and this will be delta D1. So it means delta D1 is equal to delta D2 plus 40 meters. Okay? Remember how you always wanted to add the 40 meters to the bigger one. So this will be delta D1 is equal to VI delta T, 1/2 A delta T squared, and delta D2 is equal to VI delta T plus 1/2 A2 delta T squared. Again, sub them in. So VI delta T plus 1/2 A1 delta T squared equals VI delta T plus 1/2 A2 delta T squared plus 40 meters. Now this might look wicked, but remember the VI's are the same, which means these cancel. So it'll be 1/2 A1 delta T squared, bring the other term over, minus 1/2 A2 delta T squared is equal to 40 meters. Factor out your T squared. I'd probably divide by, or multiply by 2, so A1 minus A2 equal to 80. Divide T2 is equal to 80 meters over A1 minus A2. 80 meters over 4 meters per second squared minus 2 meters per second squared, which is 2. 80 divided by 2 is 40 seconds squared. Take the square root, and you should get 6.3246 seconds. And now we're going to run out of time, but you'd fill it back in and find the distance is 1.193.8